And I'm happy to have on stage Raphael Michel, and he will talk about data internalization in Django. He is also a developer of Pretix, a conference ticketing platform system. So a big round of applause for Raphael.
Thank you very much, Jacopo. And hello from my side. My name is Raphael. I'm a freelance software developer, and I want to talk to you about data internationalization used by people to translate as to developing, which is called Pretix and is a conference ticket shop or ticket shop for any kind of event. One of the core features is to enable event organizers to communicate with their participants in multiple different languages at the same time. And that means that not only the application itself needs to be available in multiple different languages, but also user-inputted data, like in our case here, the names of the various tickets need to be available in multiple languages. So we somehow need a way for the user, in our case the event organizer, to input data in multiple different languages and then store this data into our models, into our database, and later display the correct language to the user. Unfortunately, there's nothing like that in Django. But surely there is a Python package out there that we just need to install and we're ready to go. So the good news is there is such a Python package, and the bad news is that I counted now less than 18 of them. So I want to do a quick survey. Who of you ever used one of them? Okay, that's quite a lot. You used more than one of them? Okay, so I'm only focusing on the top 6 ones here. They're printed in bold. They are Django Parler, Django Val, Django Neche, Django Model Translation, Django I-18 Enfield, and Django Klingon. I'm really thankful the author of Django Klingon didn't give it a name in Klingon. So I'm only focusing on those because those are the ones that appear to be actively maintained. That doesn't mean that the other ones don't work, but from what I could see, they're not that actively maintained. Full disclosure here, I'm the author of I-18 Enfield, which I built as part of Pretix and earlier this year refactored out into a standalone library. So where do we go from here? Unfortunately, I'm not able to say you which one of those is the best package to use, because they are very different in their design and therefore also very different in their advantages and disadvantages. And depending on your application and on your personal taste, it can be a very different choice of which one is the correct one for you. There are multiple things we'd like to know when evaluating these options. The first one is that we want to look at how the data is stored. This is very important because there's a chance that your relational database and your database design will outlive your application, or that for any other reason you want to be able to access your data from a different application that might not be Django-based at all. So we wanted to have a clean database layout that we can easily use from a different application as well. We also want to know how their Python API looks like, so how do they change the way that we interact with our models, with our model instances, and with our query sets. And we are also interested if they provide any additional features. For example, do they have great integration with Django admin or with forms or something like that. And finally, we also want to know if they have a performance impact on our application, and if so, how large it is. For all examples in this talk, we'll be dealing with a very simple model. Since we're in a cinema, we want to store a list of movies, and we keep it very simple. For every movie, we store the title and the year. And later, we want to be able to store the title in different languages at the same time. So let's first look at the database layout. For the database layout, we can identify roughly 3 different styles among those 6 packages. The first one is to keep the translations in a separate table. This is what Django Well and Django Parler does. Klingon does it a bit differently. We'll go into that in a minute. So the idea is that we have our primary table for our model data that is not translated. In this case, our movie ID and the year. And then we have a separate table containing the translations with one row per language. For example, one row for English and one row for Italian, and then a foreign key field that refers those rows to the single one in the model table. Klingon has only one table for all of your models and uses a generic foreign key to refer to the original model, while Parler and Val have one translation table per model table. This design of having multiple tables is very clean when looking at it from a database point of view, because it's how you probably should do it in a relational database. If you are interested in only one language at a time, you can very efficiently fetch the translation together with the model data using a join. We just learned how to make joins efficient with indexes, and in modern databases, simple joins are very cheap. But it might be more expensive to get all languages for our model instances. And in the case of Klingon, where it uses generic foreign keys, which our database knows nothing about, we cannot do any joins, so that's probably more expensive. However, this style requires the most changes on the ORM side of things, because we need to generate those joins and we need to generate those additional tables and so on. So it adds more complexity on the Python side. The second style that we can see is to have separate columns in the same table, and this is what Django model translation does. So we have only one single table, and we have a column for the English title and a column for an Italian title. So we don't need to perform any joins, and we can, by constructing our select query to the database, we can just select one language or all of them, and it's very cheap. The downside is that we have to change the schema of our database every time we want to support a new language or drop support for a language, which might or might not be feasible for you. And the third style that we see is to have a compound field that stores the data for all languages in one single column. This is the less cleanest in terms of database design, but it makes a lot of things easier on the Python side. It's, you can either, in the Django I18N field, there's just JSON data stored into a text field, and in the Niche case, it's a PostgreSQL JSON-B field. In the case of just storing JSON text in a text field, we lose the ability to properly index and filter that data, which might or might not be very relevant to you, or doesn't matter at all. With JSON-B field, we're retaining this ability, but we're being Postgres-specific in this case. So now that we've seen three different styles of database layout, let's look how those packages change the definition of our models. And again, we can identify three different styles here. The first one is that we have to use a custom base class. They are called a bit differently in the different packages, but it's approximately the same. We inherit not from db.models.model, but from translatable model. And then we either have like a container descriptor here that contains all the fields that will later be available for translation, or we have an additional property on our meta class that we can use to define the set of fields that should be translatable. The second style used in Django I18N field is that we just require a custom field type and don't have to change anything about our model class. Everything is contained and done by the custom field type. This obviously isn't possible if we want to have separate tables, but it's very simple and self-contained for the case where we just store it to one single column. And the most complicated approach is done by Django model translation, where you keep your model as it is, as a plain Django model, and then in a different file register a translation options class. This makes it less obvious when looking at the project how the actual database looks like, but on the other hand, it makes it possible for you to add translation options to a model that might live in a third-party app and that you don't really are able to change. Now that we've seen the different styles of model definition, let's also look at how to interact with the model instances. And again, we can roughly identify three different styles here. The first one is the popular one in Django Well, Parler, and Nietzsche, and it is that we normally work with one language at a time. So at query set time, we specify a language, or if we don't, it's using the globally active language, and then it pulls the data from the database only for that language, and we have the .title property that contains the translation in that language, and we also can set that translation by modifying the title attribute. And if we want to work with a different language, we have to change the current language first, which, depending on the implementation, might or might not cause additional database queries. With model translation and I18N field, we work with all translations at once in our objects. So in the model translation case, it's just different columns on the same table, so we can just access the raw title_en, title_it attribute, or we can use the magic title attribute that will always return the value in our currently active language, but we don't have to, and we can manipulate them as we want. And in the I18N field case, the title property will contain a special data type that behaves very similar to the getTextLazy function from Django's translation framework. So the data type contains the information of all the languages that we have defined, but as soon as we cast it to a string, or if, for example, by printing it or outputting it into a template, we will only get the value of the currently active language, which makes it very convenient to use together with the getText utilities. The third style used in Django Klingen is that the title attribute always just contains the default language, and that we very explicitly get and set translations for our fields from the database using helper methods. So this has been a lot, and there's even more that we could talk about and compare, so let's try to get an overview. We shortly talked about the database layout, and we've seen that Parler and Val use a separate table for every model and to store the translations. Klingen uses something similar. It uses one table for the whole project and then uses a generic foreign key to refer to the main model. Model translation uses different columns on the same model to store the translation data, and Nietzsche and I18N field store all data within one single column. As I said before, Nietzsche uses PostgreSQL's JSONB field, which also means that for all of them, they have the same database support as Django has, except Nietzsche, which only naturally supports PostgreSQL database. I haven't gone into filtering the data, so Parler and Val include proper and explicit support for filtering based on the contents of the translated field, and they provide you with the required joins to do that. Klingen doesn't really have any support for filtering, and this is also hard to implement because your database doesn't know about the generic foreign key, and it makes it, you cannot really do an efficient join, and it's hard to implement a filtering there. For Django model translation, it's easy again because it's just different model attributes, and you can just filter on the title_de, title_en field. In the Django Nietzsche case and the Django I18N field case, it's harder because, well, it's JSON in your database. Nietzsche, using PostgreSQL's JSONB field, should be possible to get really decent filtering and indexing support on. However, I couldn't find anything in the Nietzsche documentation on it and couldn't get it to work, so that might be something interested to sprint on. In the I18N field case, as we're storing plain data in the database, you're a bit out of options if your database doesn't understand that you can only do very complex things and achieve very limited quality in filtering there. We also talked about model definition, and we've seen that Parler, Val, and Klingen, and Nietzsche require you to use the custom base class and then somehow specify which fields you want to translate, while you have that more complicated registration-based approach with model translation, and you have to only use a custom field type with I18N field. We've also seen how to operate with with model instances, where in Parler and Vel you operate on one language at a time, and in Nietzsche as well, and in Klingen you are very explicit about everything you do, while in model translation in I18N field it's easy to operate with all of them at the same time. I haven't gone into detail on forms support. Both Parler and Vel come with a custom base class for model forms that you can just drop in and use instead of Django's model forms, and it will easily let you manipulate and show the data in one single language. So you can have a form that allows you to edit the data in the currently active language of the user. In Klingen and Nietzsche, I couldn't find anything on form support. And in the model translation case, you can just use plain model forms and decide for yourself which fields you want to add to the form. After all, the translations are just different fields in your model. In the I18N field case, the custom model field type comes with a custom form field class, which comes with a custom widget that allows you to edit the various translations within one widget that is composed of multiple input boxes, which is what you've seen in the screenshot before. I also haven't talked about admin support so far. Parler and Vel have very great admin support. It just works out of the box. Whereas Klingen and model translation and I18N field somehow have admin support. In Klingen, you can achieve it by adding an inline to your model admin that just filters for the correct translations from the translation table. By model translation, again, it's just attributes on your model like any other, so they occur in the admin. Might be a bit, if you support a large number of languages, this might be a bit confusing, but it works. And in I18N field, with a few changes that could be improved, you can get the custom widget I talked about within the admin, so you can also easily edit all languages at once. In the Nietzsche case, the admin currently only shows the raw JSON data, so this is also something that would be interesting to improve. Lastly, I want to talk about performance. The Vel implementation is pretty quick because it makes efficient use of joins. Also, model translation only needs to fetch the different columns, and I18N field is in my tests also pretty quick in parsing the JSON data. So they are all approximately in the same range. Django Nietzsche is a bit slower in my tests. I don't know why. I don't know the internals of PostgreSQL's JSONB field. Maybe I'm just measuring badly here. The more interesting ones are Klingen and Parler. Klingen cannot do any joins. And in my tests, Parler also didn't do any joins. Either I'm doing something wrong here, but I assume that they're deliberately not doing it to avoid some not that clean changes to the query set and API that Vel does. But on the other hand, Parler and Klingen both come with out-of-the-box, enabled by default, proper support for caching. So they make up for that disadvantage by doing caching automatically for you. So I believe all of them are suited to be used in practice from a performance point of view. On my GitHub page, you can find all code that I wrote while evaluating the different options. It's not much, but it's very short usage samples for every one of them. And with that, I'm at the end of my talk. If you want to spend some time at the sprints working with me to improve I18N field, or even any of the others, although I'm not an expert there, I'd be interested to work with you. Also, if you're interested in working on prefix and thereby contributing to a larger sized open source Django application, we always have issues for every experience level, and I'm always happy to mentor anybody. We also have commercial support and hosting to fund the Pretix project, so if you're running events of any kind, please come talk to me. I'm here all week. With that, I want to thank you very much for your attention, and I'm happy for any questions here or later on Slack or in the next break. Thank you very much.
Thank you, Raphael. We have quite a few time for questions, so please, if you're keen to make some.
Hi.
Hi. So what do you use for translation strings? Transifex, Rosetta?
Currently, I'm only having PO files in my GitHub repository that I'm... So, to make this clear, he's asking about translation strings, which is not really related to this one, because you're asking for translation strings of the application.
Yeah. It's for internalization in common for the whole projects, because if you translated the content, you also need to translate the strings for whole site in order to make it available in this language. So yeah.
Okay, so for the content, the translations are inputted by the user. For the application, currently I'm just using PO files in the code repository that I and the translators edit with PoEdit, which is a GUI tool for editing them. I use Transifex in a different project, not yet here, because I find it quite a hassle with the synchronization of the files. Otherwise, Transifex is fine, and I believe there are other options that are also fine too.
My question is actually also about crowding and Transifex and all these options. So these are really tailored to come into the static files, so the static text strings. And is there any, is there any package or any such internationalization package that addresses the strings in the database for translation on, say, Transifex?
Not that I know of, and it also would be hard because I could imagine valid use cases for that, yes. It would be hard because strings in your database can change all the time. It probably wouldn't be that huge thing of it to do something like this in your site yourself, because it's just models and forms. You can also build something to output that and pipe it to Transifex. They have a command line client and an API. I don't know if it's worth the effort, but it could be interesting, yeah.
Hello.
Hi.
One thing you didn't cover is that some of these packages, they do not have a full ORM support. For instance, if you want to do complicated stuff with only defer and that kind of things. And
yes.
They have very limited support, so you start building something and you end up knowing that actually your performance sucks.
I don't know if the performance, because I only ever built a large project with one of them, not with all 6 of them. I only could test very small cases for the performance. Yes, when working with the translated fields, especially those you need to do custom joins, they limit you in some query set API features.
It's a HVAD I'm complaining about.
Yeah, so some of them limit you in your API features. Obviously, those 2 won't, because they're not doing anything about your queries. They are a step afterwards. But with the others, well, you can always fall back to writing custom queries. But yeah, you're losing some ORM support here. That is correct.
Hi, I'm using Django Parlay. I just wanted to know what was the motivation for you to start, I think it was 1 year ago, to start yet another model translation, field translation field for Django.
Actually, it was way more than 2 years ago.
Ah, okay.
So the main motivation was that in my case, it's all about the event organizer who needs to work with all languages at the same time, especially in forms, which is cumbersome with Parlay. And also, I really like the Python cleanness of I18N field, because for people writing templates or contributing to any display logic, it just feels exactly like the getTextLazy method.
Okay.
So if you have any further questions, I'll be around and always happy to talk to you. Thank you very much.
Thanks, Raphael.